Hello, this is Garrett Keane. I'm continuing the series of short videos showing how to carry out a Telemac simulation or model of the Shannon estuary. This video will focus on post-processing. That's how to animate results such as tidal elevations and velocities in the estuary, and also how to download time series so you can make comparisons with field measurements. The first thing we need to do, Blue Canoe is open. We need to open the file, the results file, and I have it here already. It's in this directory, and this one is called Shannon A2 and has the extension SLF. It takes a short while to load it in, and in this particular simulation steering file we output the U and the V velocity, the free surface, and also the bottom elevation, which is the bathymetry. The first thing I'll look at is the velocity, the free surface. In fact, I'll bring that down, and you just bring it down into the window. I can pull back here to scroll out so we can see it a bit better. And then the first thing we look at is how to animate it. If I just right click and select animate, you can see up here that we get a timeline. Now this model only ran for a short while, but what I can do is go through it frame by frame. The initial surface elevation, everything is set to 0, but if I come to the properties and put on the scale and switch it on, and we can customize that scale to have equal intervals. For the moment I'll just leave it like this. So you can see that we're blue here, so it's actually a value of 0. You can see 0 is the value. Then what happens as I animate it, first of all I'll step through it frame by frame. So if you remember, we output at 15 minutes, so it'll take a while because it's starting off initially. It'll take a while for us to get some results. 1 hour 40. Now we can see the tide beginning to propagate in. And you can see the tide is moving in to the estuary. You can see the elevation here is a bit higher now. It's up to nearly 0.4 of a meter at this zone here. If we keep going, you can see that back here is 0.8 of a meter, and the tide is moving in from left to right. So it's very useful to see the tide actually propagating in. You can see you have your maximum tide up here close to 1.6, 1.8. So, and that's it there. Now, if you want to run it as an animation, you can just click this one, bring it back to the start with this button up here, and then press play, and it starts to animate through. It goes very quickly there. Also, what we can then do is if I make this one invisible and I bring the velocity down, and we then animate the velocity, what happens here, if I go through step by step, now nothing is showing here because the velocity will, the velocity is initially set to 0, so I'll just keep stepping through it, and shortly enough we'll see something happening. There it is. The first velocities are showing, and you can see here that it plots the velocities as vectors. Once again, I'll put the scale on, the legend on, I'll just move it down here out of the way. We can keep stepping through, so you can see the velocities are still very low, but in here, because you have a narrowing channel, you start to get large values. Same over here, and we can see the velocity is developing. You're getting a lot of rotation here around the islands, and we're getting very high velocities over here. Now once again, you can scale these velocities. These could be spurious velocities. In these sort of cases you need to go in and refine the mesh if you need to improve it in those locations. And that's it. As I say, I only ran this model for a short time. So that's how to animate both the free surface, which is a tidal wave moving in through the estuary, and the velocity profiles, which shows the velocities as vectors, color-coded vectors. The next thing we need to do is, on the free surface here, is to come Tool, Extract Time Series. Now it says at multiple points. So what we need to do first of all is define our points. And I'm going to just pick some points by eye. You need to be more specific in your report. Say I pick a point here, I think Carrigaholt might be around there somewhere, but you need to double check it. We wanted a place in at Limerick, and maybe some of the other places, Tarbert, I think is down here somewhere. So you need to locate these places yourself, and then I just press back up here to close it, and I'll say tidal elevation. So I'll pick the points where we want to compare the elevation of the tide against field measurements. You can also pick other places as well. If I then come to free surface, tool, extract time series at multiple points, I now, because I've created this XYZ file at those locations, I can now extract it. Now what I need to do here is it generates free surface here, and underneath it generates a table. You can basically this one up here, properties, this one here, I can say view as table, and you can see it has the data here in tabular format. Like I said, I only ran it for a short time. Also what you can do is file, save. Now here, this is the one. It's the one here, and I save it. Now if you come here and select CSV, this is a format that comes up as an Excel file, and you're able to open this in Excel. So we'll say Shannon A tidal elevations, and I save that, and you're going to be able to open that in Excel. And then if we need our velocities, I can we'll pick some different points for the velocities. Say you want to look at suitable locations for tidal. First of all, our comparison point is somewhere in around here, where we have field measurement data, but also you may want to pick points that might be suitable for a position in a tidal gauge. So I'll pick some at random, but you're going to have to investigate yourself what might be suitable locations. I say OK here, and I'd say Shannon A current, tidal currents. Say OK, and this time we click down on the velocity thing here. We can do it up here, and we go tool, extract time series at multiple points, but now we're going to do it at the tidal currents. One of the points I picked isn't on within the grid. I'll just say OK and cancel it. It will just miss out on that one. If we come and view as table, you can see it basically plots the points with amplitude and direction. And remember, 0 is normally vertical north, so this would be 257. Well, 90 here, if 0 is vertical north going clockwise, 89, 90 is basically in the east direction. 270 would be in the west direction. That's it. It didn't plot the one that wasn't within the zone. Once again, if we want to save this, we can come to here, file, save, and once again, no, that's the wrong one. I think it's this one we have to save, sorry. In this case it's this one. File, save, and it's the CSV, so we'll call that Shannon A, or whatever name you want to give it, tidal currents. Once you have that, you're then able to compare it with the experimental values that you have at the single point, and you can also just look at the velocity profiles at points where it might be suitable to put a tidal gauge. Okay, I think that's everything that you're going to need. So thank you for listening, and good luck with the assignment. Okay, thank you, bye.